Well, I think I've always known I wanted to be an engineer. I realized that pretty early in life. And I became very enamored with computers. This is going back into the 1970s time frame when computers were really big systems and they had very little computing power. I had a chance as a young teenager to spend a week at an insurance company and program a bit in RPG and understand what it takes to actually take and create some punch cards and write a program and watch what a computer can do. And I think I was fascinated from that very early day. You have to recognize how difficult it was in those early days to get access to computers because the computer time was so incredibly expensive and the power of these systems were so little that it was all about optimizing the computer time, and people had to do all this work so that the computer's time was fully optimized. And I think back to that, and I think where we are today, and it's almost exactly the opposite right now. So one of the challenges that's really upon all of us right now is that the computing power that's being handed to us is being handed to us in a way that's highly parallelized. You know, we lived in a wonderful era of time where computers just kept getting faster, the clock speed just kept getting faster, and the problem of programming was very much a linear one. Well, about 10 years ago, it became clear that the physics didn't allow Moore's law to continue to be applied in the form of a single core, a single processor. And so now we all, as an industry, face this challenge that to utilize the incredible computing power that's being delivered to us, we need to understand how to operate in a parallel world. And so the original investments we made in high-performance computing and the increased investments that we've been making in technical computing all up are really about helping engineers and scientists and business people to utilize the power that's being delivered to us in the form of many core systems and to simplify the process of building applications that take advantage of all of the power that exists within the parallelized cores that are delivered in these chips. That's a hard problem. It's a very hard problem because software engineering by its nature is a linear one, and it's much simpler to solve it in a single core. But it's not the hand we're dealt. We're now dealt a hand where we have to enable and unleash the power of these new chips by enabling and making it simpler for developers to write many core applications that are highly parallelized. And there's been massive investments that have been made, certainly in companies like Microsoft, but in other research institutions around the world to help to unlock all of that power and make it simpler to build these applications. It's a non-trivial problem, but we understand a number of techniques that can be used to make it easier for people to write these applications. So as long as the computing industry is being provided with this vast amount of ever-increasing power, the opportunity to harness that and to take that to solve new problems really becomes a software challenge. A challenge where if we can build systems that put this power to use, solving engineering and scientific problems, enabling people to get insight into the vast amount of business and scientific data that they have available to them. That's the things that I think will be game-changing on a go-forward basis. The power is there. The computing power is in our hands. It's a software challenge that will enable us to fully utilize what that power can bring. And that's really what Microsoft is all about, and that's what we're doing with this technical computing initiative. You know, when I see trends and things happening in the computing industry, the shift that is beginning right now with the cloud is one of the biggest changes we've ever seen. And one place where it will apply very significantly, and maybe even first, is in the technical computing space. Because technical computing is one workload that can use all of the resources that can be delivered by the cloud. So one of the challenges that exists, particularly in the technical computing space, is that it's hard to pull data together sometimes. Getting the massive amounts of data that's required to really understand the technical computing problems has been a challenge for people. The cloud is one place where we can really simplify that. There are a large number of data sets that can be made available to everyone in a very cost-effective way by putting it up in the cloud. Microsoft has taken a first step on this with a project that we call Dallas, a codename Dallas, where we're working with government and academic organizations that are producing these very important data sets, whether it's census-specific information, geophysical information, or also commercial data, taking and pulling all of those things together and making them available in a very easy way and a very consistent way for applications to build on top of, but also to be made available in a much more cost-effective way than was ever possible before, because it'll all be available in one place, in one easy way. So the potential associated with bringing all of this data together in Dallas and all of this computing resource together with Windows Azure is to pull those things together to enable simulations and model designs that were never possible before. Certainly never possible at the cost that is available here. You know, in the past, the cost associated with putting together an HPC cluster and getting all of this data, getting it in a place where it's available, it was prohibitive to many organizations. One of the great promises that the combination of Windows Azure together with Dallas provides is to take that, put it together in one easy package that's incredibly cost-effective and is now available to everyone all around the world. That's the sort of thing that I think the cloud enables that's very unique and where technical computing applications will really benefit. I think that the work that we do is really ultimately all about helping people to live their lives differently, to do their jobs differently, to help them find new things that they couldn't find in other ways, and to enable scientific and engineering discoveries that wouldn't be possible without the combination of the incredible computing power together with the magic of software. It's the ability to help influence that and help drive the industry, ultimately to help people all around the world, to bridge the digital divide, because I see computing as one of the key things that can help the billions of people around the world that aren't living at the same living standard that those of us who are more fortunate in. And by being able to reach out and do things that help them communicate with each other and understand what's happening in the world and become more productive, we can do so many things to help so many different people. And at the same time, in the developed world, there's so much that's left to be discovered, so much left that's to be found. People say, well, we've seen so many changes over the last 10 or 20 years, and I'm very confident every day that we haven't seen anything yet compared to what will happen in the future.